Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at troubleshooting IP connectivity. We'll be discussing the components of troubleshooting end-to-end connectivity and end-to-end connectivity problems that initiate this troubleshooting. And then we'll look at the 8 steps we're going to go through to troubleshoot this end-to-end connectivity. Step 1 is verify the physical layer. Step 2 is check for duplex mismatches. Step 3 is verify addressing on the local network. Step 4 is verify the default gateway. Step 5 is to verify the correct path. Step 6, verify the transport layer. Step 7 is verify your access control list. And finally, step 8 is to verify your DNS. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. A lot of times, one of the best processes to do troubleshooting for end-to-end connectivity is the bottom-up approach. There are 8 steps in this. First thing we do is we look at the physical layer. We want to make sure that the easiest way to look at it is, do you have lights? Is that cable connected into my device? Is that connected into the switch? Is there some sort of light? Is that physical layer up and running? Then we check for duplex mismatches. Is one full duplex and one half duplex? If that's the issue, you're going to have communication problems there. Then we want to verify our addressing on the local network. You want to verify your IP address. Then we also want to verify our default gateway. We want to make sure that we're taking the correct path. We want to verify our transport layer and then look at access control list and DNS. To start out troubleshooting your end-to-end connectivity, the 2 main tools you're going to use are ping and traceroute. You're going to be on one PC or server or device, and you're going to try to communicate to another device. How I personally do it is, first I use ping. So first thing I do is I use ping, and I try to go for the home run. So I go from PC 1 here all the way to my destination, which would be server 1. I'm hoping I hit that home run, hoping I get lucky, and it works. But you're troubleshooting, so there's a problem and it doesn't work. Then what I do is, if I don't get that home run right away, I do a trace route. Now it's spelled Traceroute when you're on a Windows device, and it's spelled TraceRT when you're on a Cisco device. They do the same thing, but just be aware that there is that difference. What you would do is, from your PC1 in this diagram, you'd run a trace route to the server. Now, ping sends that echo request all the way to the end device, and it comes back. What traceroute does is it uses a stepped approach to go to each hop, each router, and see if there's connectivity. And it uses ping to do that. So traceroute is using nested pings. Traceroute would first send a ping up to R1. Can I ping that? So that would be the first traceroute ping here. You'd come back and it'll tell you it's successful or not. Then the next one, it would go and it would ping R2. So that would be the second traceroute ping. Can I reach that or not? Then it would go and it would ping the next hop. That would be R3. So this would be the third traceroute ping. And maybe here is where it breaks. And when it breaks right here, you know there's a problem in this general area. You have ruled out that the problem isn't necessarily to R1 or to R2, but it's after R2 is the problem. So you can start looking in this area. Was I able to ping this IP address right here? Yes or no? Am I able to ping this IP address? Do I need to look at the configuration on both sides of this connection? Traceroute will allow you to ping through each hop, each router on it until it breaks. Then that'll give you an idea of where to troubleshoot. Once again, I use ping the first time to try to do the home run. And then if that doesn't work, then I use traceroute to the destination, but then it pings through each hop. Each one of these routers, it'll ping where it stops working, gives you an approximate location of where that problem is. Once you've verified there's a problem, we go to step 1, and we're going to look at our physical layer. One of the best ways to do that on a Cisco device is do the show interfaces and then tell it what specific interface are we looking at. When you look at that specific interface, we can see some information about it. First things here is showing that it's up and up. Now, if it was administratively down, that means somebody did a shutdown on it, or there was an error that caused it to go into disabled mode. So if it's up and up, then we can start looking for other things. Next one here is, this is the IP address. Is that the correct IP address? Then we can see, looking at the queues, we have the input queue. We have the different pieces of information here. We have the size, the max, the drops, and the flushes. We want these to be really low numbers. You don't want to be dropping anything. You don't want to have flushes. And then over here, once again, to reiterate, our total output drops here is 0. You want this to be a very, very low number. If it's really high, then we have some issues. Looking through here, we have some more information. We have some information about the input-output rates. We have down here, we have our input errors. So how many errors did we get coming into that? How many errors did we get sending out? How many unknown protocol drops did we have? Gives you all sorts of information here. And so you can verify your physical level. Then we move on to step 2, where we check for duplex mismatches. What you do is you go to each end of that connection, you go to each device, and then we do a show interface command here. And then you specify what interface you're looking at. And then as you read through here, once again, we have that our protocol is up and up. We have our MAC addresses. But down here, we check for our duplex. This switch 1 here is at full duplex, where switch 2 is at half duplex. Because there is an issue here, you need to go in and fix it. To fix this, what you would do is go into the interface you just checked, and you would set duplex to auto. Set that duplex to auto, then it should negotiate between switch 1 and switch 2. If it doesn't negotiate, you could go in here and not say duplex auto, but you could say duplex full. And that would set it to full duplex. But if auto is not getting you to full duplex, there's an issue. Maybe it's a bad cable or something like that. So that gives you an idea of where the problem is. Step 3, we verify our addressing on the local network. Here we are on PC1. What we can do here is list, one command we can do is an ARP-A, and that gives us our address resolution protocols, what we have in the cache. And we can see that we have an IP address, and this is the MAC address of that IP address. This should be our default gateway. Another command to use is IP config on the PCs. That will show you what your IP address is on a Windows box. On Linux, you can either use ifconfig if your OS still supports it, or IP-A. That'll also list out what your IP address is on Linux. Once you have your verified that your IP address is correct, that you do see your default gateway, it has the correct MAC address, we can go on to step 4. But before we jump into step 4, one other thing you should do is look at your VLANs to make sure you are in the correct VLAN. What you would have to do is connect into your switch. Here from PC1 here, we are connecting into switch 1, and PC1 is plugged in here to fast Ethernet 01. PC should all be in VLAN 10. So fast Ethernet should be in VLAN 10, but instead it's listed as VLAN 1. VLAN 1 is our default VLAN, and for security purposes, we don't do anything. We don't allow any connectivity from VLAN 1 here. It needs to be into VLAN 10. So what we have to do is change that. Now to change that, you go into the interface, Make sure we're in switch port mode access, so switch port mode access, and then you assign it to the VLAN, switch port access VLAN 10. Once you do that, let's go ahead and do the show MAC address table again. When we do that, we can see here that port fast Ethernet 01, the one where PC1 is plugged into, that is now assigned to VLAN 10. You got to make sure your VLANs are right. If you're in the wrong VLAN, you're not going to get an IP address. You're not going to have the access you need. You're not going to have the correct default gateway. You have to make sure that your VLANs are correct. I hope you're liking this episode on troubleshooting IP connectivity. If you have the time, please leave a comment and let me know what you think about troubleshooting IP connectivity. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. In step 4, you need to verify your default gateway. PCs, servers have one way to verify their default gateway. Routing devices have another way. When we're looking at our PC, we have our network here. This is the local area network for our PC. It includes all of these devices, the switches, the PCs, the server, and this port right here. The default gateway is the exit on and off of your network. For PC1, your default gateway here is this point right here. So you have to log into the PC. And on the PC, you have to see what your default gateway is. From the command prompt, you can use IP config or the /all. You can use either IP config or IP config /all. That'll list out what your default gateway is. Another way to look at this is you can use route print, and it'll print out the routes that your PC knows about, and it should list out the default gateway as 10.1.10.1 is your default gateway. Now on routers, once again, routers, the default gateway is the gateway of last resort. It's a static route where if it doesn't match any of the lines in your routing table, it's going to use that gateway of last resort and send it off. Here for R2, the gateway of here on R1, gateway of last resort is R2. You have to go in and make sure that's correct. To verify that, what you do is you use the show IP route command. And that will list out your gateway of last resort, make sure it's pointing to R2, and that it's properly configured. The IPv6 default gateway, it can be configured manually by Slack or by DHCP version 6. Here we're going to start off. We're going to show you the IP version 6 interface here on gig 001. Gives you some information about it. But then down here, notice it says we've joined two groups. F02::1 and F02::1:FF001. It is not part of the IP version 6 router multicast group that establishes this IPv6 gateway. What you have to do is enable IPv6 routing. To enable IPv6 routing, you type in IPv6 unicast-routing. That turns on IPv6. Then when you turn that on, it will become a member. So we can do the same show IPv6 interface gig 000, and it will show that you are now part of, which is part of the all IPv6 routers multicast group. In step 5, we're going to verify that we have the correct path. Now, this step works for IP version 4 and IP version 6. What we start off doing here is we look at our destination IP address. Is there a match in the routing table? Once again, IP version 4 routing table, IP version 6 routing table. Is there a match? If there is a match, is there a match with more than one entry? If there is a match with more than one entry, we have to we match it with either the longest bit match or the longest prefix match. And then we forward the packet based upon either using the longest match or using load balancing. So if we can match the longest bits Along as prefix, we're going to forward it using that information. If not, then we'll use load balancing. But coming back here, if there is a match with more than one entry, if there's only one here, then we can go ahead and forward our packet. The packet gets forwarded. Now, if there is no match in the routing table, is there a default route? If there's a default route, we can forward the packet. If there's no default route, we discard it. So there can be situations where if there's no match in the routing table and there's no default route, it will get discarded. So you need to make sure that you either have a match or that you have a default route. A lot of times on a stub network where there's only one connection on and off of the network, you're going to use default routes. So make sure you have that set up. And a lot of times that'll point to your ISP. Two of the most common issues that affect the transport layer connectivity include access control list configurations and network address translation configurations. A common tool for testing transport layer functionality is to use the Telnet utility. Here we can use Telnet, and what a lot of administrators do is they Telnet to a web server. They put the IP address in here, or I guess you could put a domain if you know your DNS is working, and then you specify the port. Right here, we're going to specify the non-normal port of 80, which is our web server. So this is our web server, and then we're going to say use port 80, and it's going to try to make that connection. If it doesn't make that connection, we're going to have a bad request. It's going to come back here and say bad request, and then it's going to be closed, saying that port 80 isn't working. And that'll tell you you need to go to that server, look at the configurations there for your web server. Is it actually up? Is it running? Are you configured on the right port? Maybe use the non-standard port. Have to go in and do your troubleshooting. Once again, Telnet and telnetting into that transport layer logical port number, like we did right here, is the typical way that is done. Step 7, we look at our access control list. And a lot of times ACLs are going to prohibit protocols from passing through an interface in the inbound or outbound directions. Here's a little example. We have access control list 100. We define that, and it's been incorrectly configured on the inbound interface. So we did a show IP interfaces on our serial 0. And then we filter the output by including only lines that have access list in them. And that gives us 4 lines here. These 4 lines will give us some information that the outbound common access list is not set. And going back to our requirements, inbound on S011, which is right here, should have access list 100. We don't have any. But if we look at the inbound of G00, which this command does right here, so we look at the inbound of that, we can see that the inbound is set to access list 100, where it shouldn't be. So this shouldn't be here. This should be our command. So we have to go in and change that. Now, to do that, what you have to do is you have to go into the interface where it was improperly applied. So we're going into the gig 00 interface where it was improperly applied. Remove it by putting the word no followed by the IP access group 100 in, the line that we have in our running config. That will remove it. Then we go back into the correct interface where access control list 100 should be applied, serial 011, and then we set it up, and we set that access control list 100 will be applied to inbound traffic. So you have to go in and look at your access control list. The other thing to verify about your access control list is that you are permitting some traffic going through there. Remember, there is that implicit deny at the end. Implicit deny at the end of every access control list. Before that, you need at least one line to permit some traffic through there. If you don't have any permits through there or going through there, and especially if you're not permitting the traffic you want to go through there, it's not going to make it because it's going to hit the implicit deny at the end. And finally, The last step here, step 8, you have to verify your DNS. In today's world, we know that traffic doesn't travel across the network using a domain name. It's not going to go to cisco.com. What it does is it has to translate that cisco.com into an IP address. Then that request goes across the internet using that IP address. So we have to make sure that our DNS servers are set up correctly. When you configure DNS on a device, you can substitute the host name for the IP address with all the IP commands, such as ping and telnet. If you don't have access to a DNS server, what you can do instead is use the IP host command. Here, the IP host command, what you can do is map a name. So this is the name we're going to put in here, IPv4_server, and tell it to go to this IP address. So every time we see the name of IPv4-server, go to this address instead. So IP host, the name that you want to be resolved, and then to the IP address that you are pointing it to. We can then use a lot of our IP commands like ping, and instead of putting in an IP address, you can put in the name. Here we have ping IPv4-server. The operating system then looks and says, okay, I have an entry here that says whenever I see this name, don't connect to this name, but actually connect to the IP address of 172.16.1.100. And then notice the ping here says, okay, 172.16.100 is what we're pinging. We have a success rate of 5s. We are able to do that. With the 5 exclamation marks, we have 100% success rate, and your name resolution is working correctly. It was my pleasure to provide you with this wonderful episode on troubleshooting IP connectivity. If you like this episode and you got value out of it, please click the like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.